we talked about rigid transformations. Those are the changes that occur that does not involve changing the shape or changing the size of a figure. There are three kinds of transformations that we're going to talk about here. This was the first one we talked about, actually, which is a translation, where each point is moved the same number of spaces left and right, and then the same number of spaces up or down. If you do that with each one of these points, you will move this shape somewhere else without changing the shape or the size. And that's called a translation. The thing that happens after you transform something is called the image. The original is usually referred to as the pre-image. One of them is called a reflection. And the way a reflection works, this is the line of reflection, and you need to imagine as that is a mirror. And if that's a mirror, and this is your original, when the original looks directly into the mirror, what does it see? Each point will see something else. This point looking into the mirror will see this point right here. Where is that? Well, this is a right angle because it's looking straight into the mirror. And the reflection is as far away from the mirror on the other side as the original is on its side. In other words, if you took a ruler and put it up against your nose, put the other end up against a mirror, you would be able to see that you would be 12 inches away from the mirror, and so would your reflection, because there would be a ruler there too. Okay. If you had a fly that was sitting on the mirror, its reflection would also be on the mirror. So in order to get a reflection, the only thing you need to know is, where is my line of reflection? Yeah, did you have a question?
Yeah, are we?
Yeah. You may be told where to draw it and then have to draw it yourself, yeah. Here, the idea here is that if this were like a popsicle stick, and this was at the end of it, and this was the center of rotation, your shape would spin around, and notice what happens when you spin it. What was the top is now on the right side, and what was on the left side is now the top. The entire thing turns as you rotate the shape. So here's the top. It's always going to be the furthest distance away from the point of rotation, but that means that the shape itself is turning as you're rotating. Okay. That's important and becomes a little more apparent in a moment. In order to rotate something, you need three pieces of information. You need to know where is the center of rotation. You need to know what direction to rotate it, and you need to know how far, how much of a rotation should you perform. Well, first of all, if you all just take a moment and look at the clock behind me. You see the red hand? And you see how it's moving? It's like from the bottom up around the left to the top and then down on the right side. That's called clockwise. That direction is the clockwise direction because it's the direction clocks move. Simple as that. In America, we call the other direction counterclockwise. In Great Britain, they call it anti-clockwise. But same thing. So those are really the only two directions you need to deal with in 2 dimensions when you're talking about a rotation. Do you want me to go this way, or do you want me to go that way? And then in terms of how far, we usually talk in terms of degrees. There are 360 degrees in a full rotation. 1 revolution, 360 degrees. So we have translations, we have reflections, we have rotations. And for each of them, there is something called prime notation in order to indicate which part of the shape corresponds to the part of the original shape. We give it the same letter, but because it's not the same point, this is C, this isn't point C, so we call it C prime, and that little apostrophe there is read C prime. So here you started out with triangle ABC, and when you did the reflection you got triangle A prime, B prime, C prime. And what you know about these is that AC is still the same length as A prime, C prime. C prime, B prime is still the same length as BC. And angle C and angle C prime are also congruent. So let's take a quick moment here to look at these and tell me which transformation or transformations have these shapes undergone. What's this one? Reflection. Where do you think the line of reflection is? If I asked you to draw the line of reflection, where would you draw it? Straight down the middle between the two. Yeah, that's a safe bet. Okay. What about this one? Translation, exactly. Right? It's going to move this far to the right and this far up, and every point is going to do the same. What about this one? Yeah, where do you think the point of rotation is? Up here? Okay. Now, just so that you get a sense of what that really means, let's turn this around here. What that says is, if I find the point of rotation, and I'm not exactly sure where it is, but if I find it, it will mean that every point will move the same number of degrees in its circle. Okay. So that the arc will be proportionally the same length. The angle will be the same for all of those points. Okay. What about D? Is it a reflection or a rotation? Okay. Is it just a rotation? Is there any place where you could put a center of rotation to get this shape into that position? What's that?
Not on the paper, but just below them.
You mean down here?
Yeah, not like far down, but
Here? Here-ish?
something like that.
Yeah, go ahead. Yeah, I think so. I think you'd have a hard time finding a point anywhere down here where you could create an arc and have it be the center of this piece of the circle and have the same arc be the center, have this arc have the same center. Do you see what I'm talking about? So, yeah, it needs to be translated and rotated in order to get here. The last class, they spent a whole bunch of time trying to figure out, could you rotate it twice to get it here, and I think they figured out that you could. And somebody else said, well, could we reflect it and then translate it? And that worked too. But it's going to require two moves. What about this one? Reflection. And this one? A reflection and a rotation. Okay. Would that get it there? Yeah, you're going to need a translation too, I think, in order to get this point down here again, it's going to take more than just two moves. And you might be able to do it with a series of rotations or a series of reflections. But a series of translations would not be enough.